Oh, for fuck's sakes. Okay, I think we're back. Restream. Decided to log out just as I started the stream. Okay. Alrighty. Not sure I remember, but it was been a couple of days. I need some water. I guess I could run last command. What did I even do last time? Kinda looks right. Oh yeah, okay. Doesn't need fixing, but needs updating. Right, now I need to update. Okay. Of last instruction, and then excuse me. And what is the instruction? It's a slice of U8. Where's the if here? So what I need to do is hey Phoenix. I've been good. How about yourself? Thank you for asking. I took a couple of days off, feeling quite refreshed. Don't know why I'm overthinking this so much. I need the index. Is it a const U8? I don't think so. Instructions? No, it's just a slice of U8. Looks like I was tripping drugs when stepping out of the optician due to dilation test. Okay. You say so? For this to work, I would need to return the index. Let me check the book. No worries, Phoenix. Same here. I'm feeling like half asleep, so I won't be talking much either. I'm a bit stuck. That's fine. It's gonna be a nice and quiet stream today. Yep, done this. Yeah. Done that. Okay, you only remove it if it's a pop. I should check that too. Self dot last instruction. Dot opcode. Does it go? Opcode, one word. Code is equal to code dot code opcode dot pop pop. Okay. Now we have the correct number of instructions and the right opcodes. The only thing that still makes our test fail is the hideous 99999. Time to get rid of it. The way we took care of superfluous pop-up instruction points us into the right direction by making one thing clear. The instructions we emit are not set in stone. We can change them. Instead of removing the emit call, we'll leave it exactly as is. We won't even change the 999. We'll use position field of c.last instruction again. Okay. Okay. Yeah. This is called backpatching, and common in compilers such as ours that only Drivers the AST ones and others called single pass compilers. Okay, more advanced compilers might leave the target of the jump instructions until they know how far to jump and then do a second pass over the AST or another IR. What is IR? Instruction register? I don't know. Not sure. Excuse me. That's actually right. I forgot that the previous position intermediate represent. Oh, okay. Cheers, Phoenix. I was a bit lazy to Google it, so I appreciate. I've heard of that before. Intermediate representation. The common one that is used. What? Common one that is used is their LLVM. Hiya. Inter. Now you've lost me. Do you mean it's the same one that's used in the LLVM? Okay. Where's the, yeah, previous emit call, and then add loss instruction. That's pretty cool. I didn't know that. You can get the ASCII in Vim. GA. That was like a total accident. That's pretty cool. I need it quite often. Well, sometimes. Add loss instruction. Right. So I've got the position. And the opcode. Okay, and then we need to update whatever is the width of the operand. And in the case of jump, it's 2. Yes, LLVM intermediate representation is the industry standard and is used by many things, including the Kronos Spriv compiler for GLSL. It's also used by Zig, Rust, Clang. Microsoft will also be moving to Spriv, a derivative of it, for the Model 7 of the DirectX 12 shading language. Okay, that makes sense. Thank you, Phoenix. Did you type that, or did you have to, or you could use your speech to text? Okay. We've got the whole automation set up. We'll keep emitting the 9999 while remembering where we put it. Excuse me. Okay, fair enough. Once we know where we need to jump to, we'll go back to the 999 and change it to the correct offset. Be surprised by how little code is needed to pull that off. I think because we know the width, we know the position. I know my head is a bit of a mush. It's super easy, but I can't really think it through. Are you at the ASD traversal stage? Yeah, I would say so. Hang on. Or what is the output of the parser? Yeah. Yes. Yeah, I'm going through if statements at the moment. Okay. Replace instruction, text position and the new instruction. And then just, so I guess it's got to be, got to split up. Oh, but it's already, I mean, because the numbers are 16-bit. We use the replace instruction in another method that allows us to replace the operand of an instruction. Change operand opposition int. Operand is int. Okay, and you just make a new instruction. That makes sense. And then replace it. I'm not sure what the book says, but as I understand it, when you perform this operation, you essentially traverse the data structure and locate the desired element based on the branches. You then replace a branch with a new branch, a leaf with a new leaf, or a leaf with a new branch. You mean, are you talking about the AST or if expressions? I mean, okay, AST, gotcha. I mean, if I look at what we have so far. So right now what it's doing is just recursively going through the AST and then generating bytecode. I mean, because you have the AST, it's actually a lot easier. Change operand, position and operand. Get the opcode from the instruction. Okay, you cast it. Or can you just accept an opcode here? Excuse me. Right, and you make a new instruction and you replace the instruction at the position. Instead of really changing the operand itself, yeah, exactly, multi-byte operands, change operand method recreates the instructions with the new operand and uses replace instruction to swap the old instruction for the new one, including the operand. The underlying assumption here is that we only replace the instructions of the same type with the same known variable length. That assumption no longer holds. We'd have to tread far more carefully here and update c.last instruction and c.previous instruction accordingly. You can see how another IR, that's type safe and independent of the byte size of encoded instructions, comes in handy once the compiler and the instruction it emits grow more complex. I didn't get that last bit. You can see how another IR that's type safe and independent of the byte size of encoded instructions comes in handy once the compiler and the instruction it emits grow more complex. Oh, right, okay. Maybe, not sure. Still didn't get it completely. Our solution though still fits our needs. It's saying that it makes it easier to port between machines. Yeah, that's type safe. Not sure it's talking about that, is it? I mean, I wonder if he's talking about Go, because that's, I mean, as far as I understand, that's the intermediate representation. Like he's using Golang. But not setting yourself to a certain bytecode size doesn't limit you. At least that's how I understood it. Okay. But not setting yourself to a certain bytecode size doesn't limit you. Okay. I wonder if he's talking about the operands of the instruction. Yeah, probably. Well, let's ask Cloud. Can you explain the second half of this paragraph? I wonder if that much context is enough. We'll see. Each instruction type is distinct and enforced by the type system, so you can't accidentally treat one instruction type as another. Is it because each opcode we use it separate? I mean, using the enum, which is what the opcode is. So that means I mean, okay, maybe each instruction type is distinct and enforced by the type system. Right. Independent of byte size. Yep. By a simple assumption, only replacing same type, same size instructions breakdown. Okay. Yeah, that's fine, Phoenix. Appreciate it either ways. As far I think as the whole the gist of it is from as far as I understand, is what he's trying to say is this only kind of works if both instructions that the instruction that you're replacing is the same one that's already there. Because some instructions have the instructions have varying widths of operands. Some have none, some have two. So you could, if you replace the wrong instruction, you could end up with like totally wrong code. Or your bytecode would be totally wrong. Because you've replaced. Okay. Kinda get it. I don't think. Mm-hmm. Okay, emit returns a position. Oh, I can get it to return. Mm. Now, is that the position of the opcode or the operand? Where's the emit? Okay, it returns the operand's position. C dot add instruction. Yeah, it's kind of similar. All the difference is I think here it's 16 bits, but the opcode itself is just 8 bits. Dance nothing. Okay. It limits the amount of registers available to store data and could cause register clobbering. Odd choice, in my opinion. Yeah, I mean, I thought it was odd to choose 16 too. That's what he's done, so I just went with it. Don't know why I'm having like a mental block. Can't seem to do the simplest of things today. Okay, what am I doing? Even Java and C# bytecode is 32 bits. Okay. Okay, the position is before. So position will be equal to let's make it 0. Then here position is instructions dot then. I can return position because that's where the next instruction will be added. Okay. Then instead of void, this will be okay, and then here more const jump not true position is equals to that. And it should be changed to const new true position should be self dot instructions dot len. Then I need a couple of methods. function replace instruction. Takes opcode, which is of type opcode, and then position, which is unsigned 60. Is it unsigned? Yeah. Returns nothing. Hang on, but I need a few more things. Code to replace position where you can find it, and I guess the value to replace it with. Okay, I'll update it later. Const dated instruction b code dot make the opcode, then value. Self dot allocate or is pointed to compiler. That's the updated instruction. And then I gotta replace. Set self dot instructions. Hang on. If there should be some instructions. Self dot instructions. Of opcode is equal to instruction of position I guess int to enum, or is it? I can do enum from int. in enum2. Int from float, int from enum, I guess. Yeah. Int from enum opcode is equal to instruction at position. Just to make sure I'm updating the right instruction. Dated instructions. And then start at position. Index. Self dot, sorry. It's a slice, so I should be able to update it. Instruction of I is equal to UI. UI. It's a terrible name. Dated instruction. Okay. Else unreachable. Because if the instruction's null, something's gone wrong. Okay. Guess now self dot replace instruction. This would be code dot opcode dot op jump not true, and then I guess not position value. Hang on, why? That's not correct. Okay, jump not true position, then new jump not true value. Alright, let's run the test. Must be const or comtime. Compiler 184. Comtime known, so this could be U64. $46. Yep, I don't need it there. Does not support field access. Hey Phoenix, thank you for hanging out. You have a good one. Does not support field access because it's optional. Yep. Line 77. 89. Oh, 89. And same here. One zero six. $52. Okay, guess that should be all of it. 252.25. Okay. 09. So now what I need to verify, so it should jump here. Why is there a weird space there? 1 2 0 1 2 3 4 5 6 7 8 9. Okay, now I need to know the index. If expression Shouldn't it jump after the pop? Self dot instructions dot len. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that might not be correct. New self dot instructions dot len. Why is it 9? Should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Let me check the... I mean, the replace is working fine. Oh, I know. I can check the test case. Does he update it? What is the expected position? Not up constant. Yep, here, 7. And what's the instruction? Compile. Okay, we'll use the same input. And then jump not true should be 7. What the fuck is all the rest? Is it not true? Let me check my test. Up true, jump not true, up constant, pop constant, pop. Okay. Up true with no operands. constant, no, the jump, then the constant for that's for 10, another one for 3333, and then a pop in between. And jump should be here. So what's the first instruction? That's weird. Go if expression. Self.compile condition. Condition is a boolean. Ha. Did I make a mistake there? I think I might have booleans. Is that it? So why the fuck did I do all of that? So did I make a mistake with integers too? The next step is to tell the virtual machine about true and false. And just like the compiler package, we now create a second test function. Very similar to the first one, yeah. But since we now have a bool as our expectation here, we need to update. Yep. Not the most fascinating, but we'll go through. It's fine. Without putting something on it, we get an index out of range panic. So you do still push. Hang on, but that's the virtual machine. What about the compiler? I think I might have got the two mixed up. Now I've got to go back, check integers. Instructions. Okay, test. No, that's still the virtual machine. Yeah, we append the object. Of constant. Okay, so for integers, it is correct. It's not the same for booleans. Okay, so I did make a false assumption there. These two literals, that way we always have Boolean data type in place when we add the operators. Yeah, that was the bit that I missed. So I guess here I don't need this. If b dot value code dot opcode dot up true, and if this is false, And this would be empty. Well, that means there's going to be a lot of unhappy tests. Yep. So what about the pop? That is a good question. He did say something about it. Compare pointers, blah blah. Okay, because true here should be the thing is we're not adding anything to the stack. I know we are. Pop true. Oops. False. Equal and pop. Oh, there's more. Assertion failure. Compiler 346. Expected constants total n. Does it say what it got? No, it didn't. Expected constants. There are no constants. And yeah, this one. $5.22. Oh, wrong. No. Compiler 501. This one does have constants. Oh, it should be 10 v3. Okay. Fuck, I gotta fix the virtual machine now. Zig test source virtual machine. Okay. Up jump not true. Which line was it? 33. I just leave an else unreachable for now. What the fuck? That was not supposed to pass. Up true. Okay, I do push an object. It's interesting. Let me just verify. Checked. Right. True, false. Okay. It's a short detour. Compiling conditionals. Thing. This is done. Yep, that's done too. Compiler. You know, the weird thing is, now I don't know how the virtual machine tests have been passing. Is there a test for true? Because there were no of true or of false. That's fucking weird. Yep, done. All this is done. It's replaced. And it works. Yep, that's done too. And we gotta compile consequence. No consequence, sorry, alternative. To do compile alternative and jump. But before we still gotta execute this. That's the compiler bit. Oh, okay. He added one with the alternative. Hang on. Yeah. I guess I can do the alternative. I can do the execution tomorrow. Because I think alternative now, say if true, 5, else 25. So there's condition, true, up, constant, 5, up, jump, not true, else, position. So we've done till here. Now we have up, constant, 25, and here we need jump after 25. If true. So I guess I can just do that. 6. Did I just put 100? Right. Jump position. This would be up jump. Right. And then self dot compile ast dot node statement is equal to a block statement, which would be if expression dot alternative, which is optional, if I understand correctly. Equals yep, it is alternative, sorry, optional. So if expression dot alternative compile this, and then okay. So what if, right, it doesn't matter. Compile const new jump position, new jump value. Self dot instructions dot len. Replace instruction jump position, new jump value. Can remove that. Okay. So if there's there is a alternative, we'll compile it and the number of instructions would increase, and then if there isn't, it won't, and then you just update whatever it is after. Okay, that wasn't too bad. Yeah, this one. Oops, excuse me. True 10. I'll use the same test he tested, so that way then up true, jump not true, constant up, then constant pop. There should be a jump here. And then 13. there's a problem I can notice right away. But before that, jump here and then add a constant, pop, and then add a constant again. One, two, pop. Yep. Except that the input now contains alternative. The problem I was thinking of is here. What if it's else if? Let me check parser. Parse if expression. I forgot to update the title today. Hey Schoolie B, how you doing? Yeah, I'm good too. Just figuring out how to compile if expressions. Expect peak. What's my language syntax? It's very similar to JavaScript, I would say. Yeah. I mean, it's fine. It's just a regular if statement. Not sure yet. Maybe towards the end, I'll consider adding types. If I still want to work on the compiler, that is, at that point. Not sure. Let me run the test for now. Compiler. Okay. The jump is way off. No, it's the opcode that's off. 15 and that one's 16. Yeah, it is 15. Let me check the test. Actually, an assertion should have failed to 20. I guess it never got to that point. Up true, jump not true, constant. Jump not true is A, B, C, D, E, 14, 15, 16. What is it? Yep, jump not true is 7. That's the first constant. Then this should be jump, or maybe I missed. Expected F. Up jump. And it's the value. Hang on. I'm not sure I updated the value. New jump value, jump position. Yeah, I do. Yeah, Schooly B. I've been enjoying. The more I write Zig, the more I'm liking it. I think thanks to this project, my understanding of Zig has gotten a lot better too, which is quite nice. That was also like a goal of mine, to get better at Zig. What am I missing? I forgot, were you trying to learn Zig, or was it Odin that you were doing? I think it was you, or might have been someone else. Odin, yeah, okay, yeah. You, how are you liking Odin so far? We built anything new on it after the last time we spoke? Yeah, I remember now. Ostrich DB. And you build in Ostrich DB Lite, if I remember correctly. The last time we spoke. Okay. How long do you think you would need to finish it? Okay, nice. That's not, well, I mean, early July. Okay. That's actually not that far away. Do my tests make no sense? Going to have the stream open, but we'll be gaming. Okay. I mean, once I finish this, I'll come say hello. Do I have to remove that extra pop again? I don't think so. 7. So that's the pop. That's correct. That's for the last constant. So up true or 5. Jump not true. D, E, F. Yeah. And then 7. Yep. And then up constant for 10. Yep. 0 is the index. Then up pop. Why? Why is there a... Okay, because there isn't. My bad. Should only be 2 pops, really. 1 and 2. Yep. Jump up constant. What's that for? Okay, that's 10. And then that's where you should jump to if it's... No. That's what the jump not true is for. No, actually it's correct. Okay, I messed it up. Where is it? If expression. So the jump is for when the condition is true. It should be after the consequence. Yep. And it should jump once the alternative is compiled. Hmm. Yeah, so that is jump, constant pop, constant pop. Mm. Okay, so where am I going wrong again? So that's the first constant here. And then there should be a jump statement, which is... Hang on, there's no pop. Okay, because we do have one at the end. But then where's this pop coming from? Expected this. I think my expected and got is swapped. I think this is the test. Append expect equals slices. No, fuck. Fuck, that is the expected instruction. Where's this coming from? True, not true, constant, jump. Jump is... Yeah, this is correct. Something's weird. Am I running the right test? Sig test source compiler. Where's this pop coming from? Okay, let me change this to an 8. Okay, that is weird. Take build. Five one six. Yeah, something's weird. Can I clear zig cache while testing? Zig build clean. Zig build clean. Really? Zig build. Zig build new. Hang on, unless it's this test. Yep, that's a possibility. Let's try that. Source compiler. Okay, so it's the first test. I mean, which makes sense because I need to update the first test too. So there needs to be a jump statement. Why don't I just get rid of that? It's the second test. Test both things. Okay. Oof. So 0 E instead of a D. That's just before the first constant. Okay, so the jump statement is off by 1. And there's an extra. Oh, okay. Because I gotta remove that pop. of compile. Okay. Compile conditional statements. Okay, I think that'll do for today. I'll do the execution tomorrow. Oh, jeez. Okay. I guess that's it. Thank you for hanging out and hope you have a good day ahead. And I shall see you tomorrow. See ya.